if you want to kick a tiger in the ass, you better have a plan to deal with his teeth. And that was a Tom Clancy saying. Another saying is, don't awake a sleeping giant. That was, I believe it was a Sun Tzu quote. Now, with both of these, the implication is that size and market presence really makes a big difference. But today, we see example after example where it's not the big eating the small, but the fast eating the slow. Big companies certainly have difficulty being big and fast. And small companies, startups, have challenges with remaining fast as they scale. So how do we deal with that? Now, I'd venture that scalability is going to be a topic we're going to obsess over throughout this conference. We're going to talk about that in nearly every session over here. So the question I set out to answer is really, can we apply the principles of scalability that we learn as technologists and engineers to business at large? So let's get into that. Now, I've been obsessed with scalability from the beginning of my career. After my undergraduate education in physics and comp science, I landed in Bangkok, where a vacation turned into a 2-year stint with the Chicago Stock Exchange at the time that we were deploying the technology at the Stock Exchange of Thailand and its main brokerages. Now, equity trading is one of those things where performance and scalability matters a lot, where milliseconds can make the difference between making or losing money. And you have massive transaction peaks, especially with market change events like a market open. So what that experience taught me was that the considerations around performance and scalability are huge. So that was in '93. This is proof that I'm a pack rat, because this is the ad that I responded to in 1995 in the Boston Globe for a young startup systems integrator called Sapient. The BG over there stands for before Google, in case you were wondering. So I was employee number 196, and today we are 20,000 employees in 53 offices around the globe. Now, while you might never have heard of us, we've connected more customers to more experiences to more transactions to more companies than any other company on the planet. So we do amazing work across the brands that you see over here, and help them with their customer experiences by really focusing on 3 things. How do we combine strategy and consulting, experience and engineering, along with creativity, in order to reinvent how companies work and serve their customers better? So, as an example, which ties to this theme around scalability, one of the largest hospitality companies in the world chose us as their partner to completely reinvent their digital platforms across all customer touchpoints. Now, this was a retirement of their existing infrastructure, and we worked with roughly a 200-person team, which was divided into 12 Scrum teams across 2 continents in 5 locations around the globe to rebuild this entire infrastructure. It's a fairly scalable platform, and I'll go into a little bit about what that is. You'll see it's a fairly standard stack or architecture. So we've got presentation services that are based upon Play and Arca from a microservices standpoint. The same kind of thing in the domain services. The domain services serve not just the own channels for the company, but also third-party channels like the OTAs, like Expedia, and such. We use Endeca for search. We are migrating that to Elasticsearch. We have a cloud-agnostic architecture. We currently are deployed between AWS and a hybrid VMware cloud, and we are currently deploying with Ali Cloud in China. To give you a sense of the scale, we deal with roughly about 10 million shop calls an hour. Search is the center of really the scale problem here, and the reason for that is that 9 out of 10 guest stays start with a digital search. So it's a pretty material portion of the business and of the platform. So 10 million shop calls an hour, to give you a sense of how big that is, that's about 7% of the number of searches that Google sees, right, in terms of number of transactions per hour. And this has to deal with fast-changing rates in terms of the prices on the rooms and inventory and things like that. And in addition, we have substantial growth, so roughly 30% organic growth in terms of what we see on the platform, and 10% in terms of third-party growth, like through the OTAs. Now, the reason I mention all of that is that scale, it turns out, is a material issue to deal with. Now, you might say, what is scalability, right? Simply, I look at scalability as how well does a problem fit as the scope of that problem increases in size. Now, Vogels defines scalability in a little more limited manner. This is his definition. And if you look at his definition, what you will see is that he has confined his definition to really horizontal scalability. If we add more of the same type of resource in software or hardware, are we able to scale what the solution can address or deal with? Now, conveniently, I might add, for the AWS business model, horizontal scalability is favorable to their business model, but that's the way he defines it. Notice that when we talk about scalability, we're usually talking about scaling up. Scaling down is another matter altogether. Usually, when you need to scale down, it's because there is some reduction in the business and you want to reduce your operating costs. Notice also that this definition says nothing about availability or performance, though those are related considerations usually. But for the scope of today's discussion, let's focus on scalability through this definition. Now, if you want to mathematically model horizontal scalability, it turns out that there was phenomenal work done by a gentleman called Neil Gunther 11 years ago, and he proposed the Universal Scalability Law, which provides a mathematical way to model how things can be scaled horizontally. And he modeled the effects of linear speed up. I'm sorry, we don't have some of the Greek letters showing up properly over here. But essentially, if you just follow along with the colors, I'll explain what's happening in the formula. So, you've got in the denominator of that formula, in the green, the left hand that's multiplied by n minus 1, you've got alpha, which is really the effects of contention. So when you have queuing in a system, you're dealing with what we know as contention, right? You're waiting for a queued resource. And beta is in the denominator on the right. You'll see that it's multiplied by n into n minus 1, which means that it's quadratic, right? Now, why does this matter? When you look at scaling and you're adding additional resources, you're increasing the size of n, it turns out that you really have to watch alpha and beta. You have to watch contention and consistency. So, for instance, the black line, the straight line that's going up and is completely linear, is when alpha and beta are 0. As you add more resources, you're scaling linearly. Most systems in the world don't behave like that because you've got contention and coherency issues. So if you've got queuing in the system, you've got that green kind of line. So I changed contention to a non-zero value, and that's the curve that I got. You can see that as you scale resources, you're not scaling linearly. But coherency is even more damaging. So if you have essentially two threads waiting for a mutex, you're now arguing around who should write to that shared resource. That's really what coherency is. And because it is quadratic, you see that as you add additional resources, you've actually got retrograde scaling, which is why it's so important in architecture to make sure that at worst you have contention problems, but not coherency problems. So going back to the hospitality example from earlier, we spend a lot of time looking at a whole bunch of techniques, many of which up here on the screen you'll look at and say, these are super familiar. But the reason why we adopt all of these strategies, right, around shared nothing architectures, reactive architectures, we reduce contention via replication, All of these techniques are really shorthand kind of slide rules we have to reduce contention and coherency. So our architecture is completely shared nothing. Requests come into a stateless architecture. We have seamless handling of failures within that stateless architecture so that guests don't see the impact of a failed request. We're able to scale each one of the services independently, and those pods are allocated at runtime, so on and so forth. But enough about that. The topic of today's conversation is really how do organizations scale? So it turns out that corporations are the logical consequence of a quest for scale. This guy, Daniel McCallum, way back in 1856, he was the head honcho at the New York and Erie Railroad, the general superintendent, if you will. And he proposed a system of management which was based upon hierarchy and personal accountability. And it turns out that this was the foundation of today's modern bureaucracy. So he proposed hierarchy as a means to scale. Because you had to manage a large railroad, you broke the railroad into sections of track. Each track was really managed by one individual who reported into additional supervisors who in turn all the way laddered up to the general superintendent who was, guess what, Daniel McCallum. So it favored him. Now, what's interesting, and I got a chuckle out of that, is some of the language that he uses. So he says things like, great promptness in the report of all derelictions of duty, that evils may at once be corrected. God, who speaks like that today? But the reality is that while this language might be a little offensive and the discourse around management has gotten more politically correct, for the most part, most executives today still treat these principles as kind of like biblical commandments, right? Now, the reason, though, why this system worked and why he proposed this is because if you examine it in terms of the universal scalability law, it worked extremely well. In a stable system, all you had to do was to talk to your supervisor. You didn't really have a whole lot of need to talk to your peers. So therefore, while there was contention in the shared supervisor, there wasn't really any coherence issue. You weren't dealing with having to negotiate with your peers. And therefore, this system scaled very well. And this is how America built its railroads. Now notice that I said a stable system. And that qualifier is super, super important. And to understand why, we need to talk about burgers. So I know it's not lunchtime yet, but I think Big Macs are delicious any time of the day. But the reason why I want to talk about burgers is because The Economist publishes this Big Mac index, which measures the purchasing power of currencies in terms of Big Macs. Now, the reason that this index even exists is proof positive of how iconic McDonald's is in the world. Present in 120 countries, serving 70 million customers every single day, they have been innovating their products and their experiences for decades. So, starting with French fries in 1949 to the Big Mac to all-day breakfast, which just started like 4 years ago and is now 30% of sales, to even the experiences in terms of what started as a car hop to the drive-through, which is now 70% of sales, to delivery. They've been innovating for a long time, and they've been very successful at it. But it turns out that their scaling model hit a bit of a speed bump. In 2015, Easterbrook, their CEO, publicly acknowledged that in the last 5 years, the world has moved faster outside the business than inside. And McDonald's needed to change what they were doing in order to respond to what they were seeing in the market. Now, why is it that big companies have these moments where they really have an existential crisis around why their model isn't working anymore? It turns out that is driven by two things. One is the rate of disruption and customers being in control. So what do I mean by that? So certainly, we're all familiar with Moore's law. It turns out that, this price performance doubling every 18 to 36 months has been happening for the last more than 100 years. Ray Kurzweil did this study of the price performance of computing. And every 18 to 36 months, we've got this doubling of price performance improvements. So it's kind of the only industry where we improve the capability of the product and we drastically reduce the price. So this is one of the effects. And this is pretty seismic in terms of its impact to businesses, because it's not just that price performance has doubled, but as a result of this, technology which used to favor corporations now favors customers. It's not just that customers can choose and how long they'll give you their attention, but it's also that they have more choice. And the reason they have more choice is that a startup can scale from 0 to 1 million users without buying a single server, and they can leverage global supply chains without building a single factory. So customers have more choice. And big businesses are still organized around functional silos and aren't able to keep up with the rate of change. So it turns out that this is a pretty significant problem, because startups and disruptors are really working at the speed of the customer, and companies are organized in their functional silos because of McCallum. Now, the only way to survive this is to become customer obsessed, which is easy to say, but the problem is this. In 2006, our moms would tell us, don't talk to strangers on the internet and never get in a stranger's car. You fast forward 10 years, and we literally use the internet to call strangers and get in their cars. So this was impossible to predict, mind you. So if you go back 15 years, we didn't know that we would be telling Google our deepest, darkest secrets. We didn't know that we'd be renting out our houses to people we don't know, and we didn't know that we would want to know exactly when the anchovies have been added to the pizza that we ordered on our smartphones 10 minutes ago. These changes in human behavior are hard to predict in advance. So the value of speed, the ability to pivot rapidly and to orient around customer behavior, has become existential. Now you might say, hey, Sheldon, these are lean startup principles. Why are you telling us this? We all already know this, right? These three things we already know. But big businesses are not organized in this way. They're not organized for speed. They're not organized to pivot rapidly. They're organized around their functional silos and not customer behavior. But let's for a minute assume that you could make all of these three things true. Would that be sufficient to scale? Well, it turns out, unfortunately, not. A study of 40 global companies, this is pretty recent, World Economic Forum, really showed that most of these initial efforts to really work on those three things run into roadblocks. And that's the reason. The reason for that is that coherency and consistency in terms of queuing in large enterprises is a significant challenge to deal with, right? So what do we do about that? Is there a new rule book that we can follow? It turns out that there is. So from today's father of modern management. Now, we're all familiar with Amazon's two pizza teams, right? And he's been very public about that, but he's not been public about the fact that this blog post that Steve Yegi kind of leaked on his Google circles told us a lot about how those two pizza teams actually communicate. And it turns out that Jeff has mandated that those two pizza teams can only communicate through APIs. No other form of communication is allowed, or inter-process communication. So both within Amazon and outside of Amazon, these two pizza teams have to communicate through APIs. So why is that? So if you go back to the Universal Scalability Law and you examine it in those terms, it turns out that by keeping the team small, he keeps n small, right? N is the number of workers. That's kept very small. So within the teams, those teams are highly efficient. But because the teams can only communicate through these APIs, the crosstalk and contention is very low. You only need to know about the APIs that other teams are publishing. You don't actually need to know what they are working on or how they are working inside. So he has exploited the Universal Scalability Law to great advantage in a dynamic environment. So when you look at this and you say, this is great, they've managed horizontal scalability, but we need to touch on one more point, which is we've examined contention and coherency. What if we actually look at scaling up instead of scaling out? So what if instead of just getting additional developers, we get really, really smart, the 10x developers, right, which we all want to hire? So it turns out that there's been quite a bit of work on analyzing this problem, and Bill Reduchel, the former CTO of AOL, actually turned me onto the work of this gentleman, Maurice Halsted. Maurice Halsted wanted to understand why there was such a big difference between average software engineers and amazing software engineers. And so he did a bunch of work on program complexity and individual capability, and he came up with a number of measures, the most important of which he called the Halsted Length, right? Now, Halsted Length is, a way to think about it is that as human beings, at any given point of time, we have a certain number of chapters or blocks open in our memory, roughly about 7 of these at any given point of time. An average individual has a Halsted length of roughly about 250, which equates in Maurice's terms to roughly about 50 lines of Fortran code. The most exceptional individuals have Halsted lengths of 65,000 in his research and studies. Now, no other measure of kind of human performance has this much of variation, and like anything, this follows a distribution where you're going to see the high performers only at the tail end of that curve, maybe 0.5%, right? So to understand why this all matters, it might be illustrative to actually give you an example. So let's say this is the problem you're trying to solve, right? It's an image with a lot of detail and complexity. And imagine you're an individual with a Halsted length of 250, so you can look at 7 segments, each of 250 in length. So you might be able to understand this in the image. Not very interesting. You can look at the pieces that are currently highlighted, and you can understand those, and given enough time, you might be able to understand the whole image. But it turns out that you can't see the whole picture at once and all of the relationships that exist. Notice also that we don't say anything about how fast you can work or how productive you can work within the individual segments. So if you smallify the problem, you're still able to do amazing work within the small domain that you're working in, within the 7 segments that you're working in. Now imagine that you had a Halsted length of 65,000. Gets a lot more interesting. You can see a lot more of the picture. You still can't see the full picture, but if the picture was smaller, you would be able to. And certainly, a few two-pizza teams would be able to deal with understanding this full image. So high Halsted length people are actually able to deal with complexity. Not necessarily faster, but they are able to understand relationships and connections between different parts of the problem that is trying to be solved. Now, this is all very interesting. You might say, you've talked about the universal scalability law, you've talked about Halsted lengths, but what does this all mean to me? What can I do with it next week when I go to work, right? I'm going to give you 5 things to think about and focus on, and all these are based from our experiences. So first off, you need to understand what your vector that is driving change is. And in today's world, more often than not, that's around your customers. So reorganize the way in which you structure your teams around your customers, whether that be product teams around specific parts of what your customers are trying to do in terms of their jobs to be done, or customer journey teams that are looking at longer customer journeys. Really focus on that and make sure that you're organizing in that way. Now, in most large organizations, if you're a big business and you're trying to implement this, these might not be a single two-pizza team. You might have teams that are larger. So make sure that you reorganize within that into smaller Scrum teams, and those Scrum teams are working on the individual customer journey. Now, you will say that's easy to say, but all of these people, in terms of coming from different parts of the organization, how do they work together? Make sure that you're actually aligning them around the same P&L, the same set of incentives, because you got to respect that we are still living in this world where management respects the railroad model of management versus the Amazon model of management. So this is one. The second thing in here is that it doesn't really matter whether you're using scaled agile or another method of scaling Scrum or what have you. The more important thing is to look at within your structure, do you have contention and coherency? Really think about that. So focus less on the rituals and focus why you're doing the rituals in agile, and with the objective of looking at contention and coherency, and you will have far more results with that approach than ensuring that you're rigidly following process. The second thing is, in terms of orienting around customer behavior, make sure that you're using an approach that looks at all of your touch points. So service design tends to take this view that you don't just look at the point of customer interaction or even all of the points of customer interaction which you see on the left, but you're looking at all of the rest of the enterprise in terms of your people, your processes, your regulations, and making sure that you're aligning that around customer behaviors. And service design is very effective at that. The second point is you got to change your steering system. If you're an old school project manager, for decades, you have been trained that the three variables you have to manage are scope, time, and cost. It turns out that that actually makes you slower, because when you focus on scope, you've got to do a lot of analysis up front in order to make sure that you've understood the problem. And that actually adds time that might be completely wasted if the problem changes as your understanding of what needs to be done changes. When you focus on time, every project manager worth her salt is going to add buffer, which actually makes you slower. But so what instead of that, you focused on productivity, on speed and productivity, so that you can put things into production as quickly as possible rather than wait. And when you focus on cost rather than value, here it's an interesting one, because most people that will never admit that they don't focus on value. The problem isn't that people don't focus on value. It's that different parts of the organization tend to measure value in different ways. So while the business might be concerned about revenues and conversion, IT is usually measured on cost. So you got to make sure that all parties are focused on quality, productivity, and the same measures of value. And when you can do this, and you're working in short cycles, you're able to adopt a test and learn mindset, which is far more valuable in terms of adapting to change. Third, it's seldom true that you can start from scratch. You have to acknowledge that you have a certain state, and you've got to work forward from the state that you have. So use lean principles and use value stream mapping to really understand where your points of coherence and contention delays are, and then apply the right kinds of interventions. So we have a catalog of something like 80+ interventions that we can apply when we identify opportunities and value streams. They are divided into two categories. The systemic ones are focused on process and organization and optimizing those, and then engineering ones are focused on technology and DevOps and automation, which is a good segue into tooling and optimization. We're going to be talking a lot about this throughout the conference. Tooling and automation, super critical, but my advice is don't focus as much on the tools themselves, but on what those do for you. So going from 90 days to 2 minutes in terms of your DevOps testing cycles and actually understanding the major steps in that process is what is crucial, not any one specific tool in that mix. Also on tooling and automation, chances are that you have organized the way in which you do IT development into layers, and you've got different teams in charge of those layers, which means that you have queuing and coherence issues. So look at where those are, analyze them, and then look at ways to eliminate that queuing. So for instance, the automated provisioning of a developer sandbox, which brings in all of the dependencies into these developer sandboxes so that you've got developers able to really move quickly without waiting on another team to provision an environment or to give you some data. This is super important to invest in. And the last thing I'd say is really think about how you can move work to the machines. So given the number of employees we have, one of the big opportunities we see is to empower our employees with a machine learning-powered, AI-powered solution that we called Marcel. It's a virtual assistant that gives our employees 3 powers: the power of knowledge, the power of connection, and the power of opportunity. So the power of knowledge is about really any employee being able to ask and get contextually relevant results on anything else that we know within our company. The power of connection allows for the right kind of people to be found based upon similar interests or whether they've solved similar problems. And the power of opportunity allows people to connect with the kind of work and problems that they want to solve. So we are building a virtual assistant that gives our employees these powers, and we will see more and more applicability of AI and ML in really this productivity space. Now, one thing I will say on tooling and automation, remember the Halsted Length example earlier? It turns out that if you apply your high Halsted Length people to tooling and automation, you move from an additive function to a multiplicative function. Because your high Halsted Length people can see relationships and concepts far better than other developers can, if you apply them to simplify that complexity and smallify the problems so that individual developers are working in smaller domain areas, you can get multiplicative productivity rather than just merely having an additive function with those people. And this is a mistake that many, many companies make. They focus their 10x developers in the wrong areas. The last thing I will say is you got to make sure that the real things that you're trying to advance in terms of customer metrics, in terms of business metrics, in terms of developer metrics, in terms of even people happiness metrics, you're clear about where you're coming from and where you're going to. This actually is an example from one of our banking clients from last year that we set out at the beginning of the year, and it turns out that we hit all of these metrics. And the reason why we hit these metrics is because once we decided what they were, we actually made them visible all the way from the individual developer all the way up to the CIO and the chief digital officer. And by deciding what it is that you're going to do and then making sure you have complete transparency, you really have this way of ensuring that everybody is focused on the things that matter. I'll close with this. Remember, the burgers? It turns out that McDonald's got its mojo back. So from going in idea to life cycles of 18 to 36 months, they deployed a new convenience solution where you can do mobile ordering from your device, there's the devices you all have in your pockets, and pick up your burgers at McDonald's. And this has been scaled to 20,000 of their stores around the globe across 5 markets, and they did that in 9 months. Today, they are able to release on demand, and they are able to release an update every 3 to 4 weeks. And they bested their competitors in terms of ratings as well as in terms of adoption of the solution. Thank you.